to it. We were speaking about the multi-comfort. Well, if we are speaking about the multi-comfort program, and Roland now it's a presenter, I'm just going to focus very briefly on few slides before welcoming Roland to tell you a little more. So, when we are speaking about multi-comfort program, we are speaking about these dimensions of comfort: thermal, acoustic, visual, and indoor air quality. Now, in the coming 1 hour, maybe a little bit more, we'll have with us Roland Matzig. He is a good friend of the contest since many years now. He is also an architect specialized in energy efficient houses. He is one of those few that not only preaches but also walks the talk, and I'm going to show it to you. And perhaps the most important point would be that he is part of the international jury. So you are having the chance now to ask, you already had the chance to ask a component of the international jury some questions. Here I give you the chance to ask him some other questions, or to a second one some questions. Of course, I'm not going to allow him to answer about the criteria, although these criteria are public, you have seen them. But I would like to pinpoint before going to his presentation few things. Yeah, you have all seen this. Energy efficiency and thermal comfort has a direct influence over the performance of the human being. Yeah? And this is extremely important. This is why we are taking into account not only because of the CO2 emissions or the green gas emission. It is also linked with the people. You will feel better, you will work more efficient. Now, before going to the presentation, what I would also like to show you again, just allow me to find it. You will see, for example, a renovation work, this being the office and the house of Roland, as he is living here and yeah, working here. So it's quite comfortable to go down in the slippers in the morning to take your coffee in the office. This is a multi-comfort house according to all the criteria, and well, without further presentation from my side, I'm just going to open the presentation, and hopefully I will find it. Just 1 second. I believe it is this one, Roland. Yes, this is the one. Great. Now, can you switch on your mic so that everybody can hear you? No, we cannot hear you, Roland. You don't have the mic switch on.
Is that the one?
Yes.
Okay, great. So hello everybody. Something is on my screen here, but I think only I can see it. There's a question and answer display. I just got it away. Anyways, what we are talking about is reduction of CO2 emission. That's the basic driver of our thinking, and also the ground you're building your visions on for this student contest. Because consequences of the increasing CO2 emission, we all know that already, is this global warming greenhouse effect and all the following problems we have out of this, like climate changes, increase of sea levels, and all of this. I'm not talking about climate change now, but I just want you to get back to the roots. So you are able to find the answers by yourself by grounding your vision. Okay, so this is for the really first start, and one of the most important postulations of the climate scientists is that every person on the world, everyone, you and me and everyone else, should maximum put out 3 tons of CO2 emission per year, which sounds probably, depends on how familiar you are with the figures, might sound quite a lot, 3 tons, heavy weight. But if you go on a footprint calculator, a CO2 footprint calculator, and bring in your lifestyle, and you'll find out easily if you're traveling a lot, or if you are doing some things like driving a car, living in a big apartment, old house, or whatever, you will be far, far above these 3 tons. So the question is, how can we get down our lifestyle so we have less than 3 tons CO2 emission? And I can give you one answer. One big driver is the housing. So we, as an architect and engineers, are the ones who are asked in the future to level this CO2 emission. And here we have a scale of the emissions that was when we were running the student contest in Turkey. We showed this is Germany, and this was Turkey. So I have no for Spain. Do we have this? Oh, yeah, here's the Spain. Spain, we have about 8 tons per person in Spain right now. Here in Germany, we have about 10, rising a bit. I think right now we are going towards 11. But what also is interesting, the average of the EU is about 8, and the average of the whole world is 4.5. So if we are focused on this number of 3 tons, the whole world's not far away, but the whole world is China, India, the US, North and South, the huge ones, and they are changing a lot. For example, India is tremendously rising. China is still rising. So the EU might be a bit lowering down, but we have to go a long, long way. Because from, take Spain again, from 8 tons coming down to 3 tons doesn't mean that you have to change a little bit of your lifestyle, a little bit of your behaviors on the dwellings, of the size, of the energy efficiency of the houses. It is a big step. It's almost a third of what Spain is polluting right now. So what we want is to have an emission increase, which is dramatically. And to be honest, all the UE members are rising. Even they promised themselves to cut down their CO2 emission. They are rising every year, step by step, and so is the world. So we have a big thing to do. And to make it kind of easy, you look at this scale, and you find out buildings 40% of all the pollutions. That's almost the same in all the EU countries all over. It's a third the transport. It's almost a third the industrial needs like electricity and so. But the buildings, the heating and the warm water is 40%, and this is a huge thing to. And this is a huge chance as well, because if we have the buildings cut down by half or even more, we have the whole Cape showing a total different face. And what we want to do is we want to have the limit of the demand, of the energy demand, as the basic. We are not talking about how to produce it. First, we are talking about how can we realize the savings. The limiting of the demand of the energy is the major question, and that's why I like especially this year's contest because we are talking about existing buildings. If we are going to have a look at the new build, it's easy to say, okay, let's make a passive house and then it's going to be easy because passive house has low needs. No, the big challenge is the existing buildings. And this year's contest is about existing buildings. You might have the idea of adding some levels or anything at the buildings, one way to think at it. But the interesting part is how can I cut down the demand? How can I limit the demand of the existing volume of building I'm designing or I'm talking about? And then first, when this first step is gone, when this first step is done, then we are thinking about how do we get the demand produced. Of course, we want to have it renewable, on renewable basis. And if you've got this red tip, you have a little bit of left on fossil fuels, no problem about that. But the green one is the very important step, and the yellow one is the second step on top, and then the rest, you're not talking about the rest. And of course, cutting down the needs. We might have these existing buildings. I've not seen any figures, any actual figures so far, but I guess that these buildings have a need of above 200 kilowatts per square meter. I assume so. I'm not sure about that. But you definitely want to have them down in direction of, let's say in direction of, it's better if you reach it, but in direction of passive house quality, which means in the existing 25 at the maximum kilowatts per square meter a year, and in new build it's 15 per square meters a year. You might know these numbers. If you end up, let me give you a goal. If you end up with 20 or 25, be happy with it. But if you can reach the 15, super, absolutely super, but not thinking about just cutting it in half and ending up by 100 or 80. That's not the goal we're heading. So, and this passive house or these energy efficient buildings, you can consumption it is eco design in buildings. So carbon reduction comes by first insulation. That's the one and only thing. Insulate this bloody shell of the building to a maximum because it's cheap, it's sustainable, it's good for everything. The second thing is you want it to get airtight, because if you have the insulation, the airtightness gets more and more interesting. So second step is airtightness. And in this shell, in this envelope, you find all the openings, the windows and doors. Of course, you want to have super glazing and you want to have super doors. And once you have the shell, you have the envelope optimized, let's say optimized, looking at the energy losses, then you want the MVHR system, the mechanical ventilation heat recovery system, which brings you also a step higher on efficiency and gives you super air conditioning in the building constantly. Fifth point, you want to look at the light. You don't want to have dark rooms just to have a super insulated wall. You want to have very good lighting, which means look at the windows, where they are placed, in which direction they face, in which size they come along. So bring them in place that all the rooms have natural lighting optimized. And the rest, like heating system, energy efficient appliances, renewable sources, comes naturally once you have the first 5 steps done. So number 6 here, the secret of certified passive houses. You know that passive house is the only house or the only building system you can certify. So this might be a long discussion if certifying buildings or certifying passive houses makes sense or not. But at least we have a certifying system, and this system really works, which is proven since 20 and more years now. So passive house is the only construction concept where you can certify. And once you're an architect, you might have to answer this question for yourself. Does it make sense? Does it make no sense? For example, we are building passive houses since more than 15 years now. All the projects are in passive house standard. A few hundreds are built. And of course, we have not all of them certified, because certifying, we did the first ones, the first 10, the first 20, we went for certification. And then we learned how to do it properly and how to really get the house done so exactly that it's going to be certifiable. And then we learned to save this money, but we have to. We had to do this first step to come to the second step where we can say to our client, are we going to go for certification or are we going not? But if you are thinking about passive house, which has nothing to do particular now with the student contest, but I'm telling you out of the practice, go for certification, go for this quality improvement, and then you'll find out passive house is energy efficient. Absolutely, it's the best standard you can find. It is comfortable. It gives comfortable living to his inhabitants. It's affordable after a few years. All this extra investment for the energy efficient top level is gonna be paid back by the bills for running the house, and it's ecological. So more than 1,000 houses, few thousand houses have been proven these facts. So when you have the decision to go for a passive house and you ask, for example, the owners, by now they all will tell you, our owners, they do tell us, we would never want to have anything else than a passive house. And even it was a bit more of investment, maybe 3%, 4%, 5%. We do want to, we would do it again. And you'll find, I know you, I expect you're familiar with all this information. You find these houses in all kind of styles: single family houses, multi-family houses, commercial, schools, kindergartens, big houses, small houses, renovations, even on top of the mountains, in the desert, everywhere. By now, you find passive house concept, and it's running and working everywhere. And it's always following the same principles. These principles are displayed on this sheet here. Are, first of all, the envelope, which is in your student contest quite a challenge, because you can't maybe run the envelope, the insulation around the house just like that here, but that's what you want it to be. Around the house, you want to have run an insulation layer and also an airtight layer. The blue and red line here means the airtight layer, and you should, by working on your details, you should think about all these little details. How do I run my airtightness layer all along the envelope? And then the second thing, the NVHR system. You want to have an NVHR system, which means fresh air in, exchange, fresh air in the house, but warm, extraction of the air, exchange of the heat, and exhaust air out. So most of the heat stays in the house. Ventilation minimum 75% recuperation is the threshold, but you will find units they recover up to 90, 92, 93%. And you should go for these ones even in your renovation, because then it makes it much easier for the whole system to be on passive house level, because you might have some trouble to run the insulation thermal bridge free. So you can, for example, have a higher recuperation percentage, and then it levels a little bit. And the second very, very important fact is, where do I have my windows? Which quality of windows do I have? And how much of the sun array do I gain for the internal heat or cooling of the house? And you should have at least triple glazing with a low E of 0.8. If you have 0.7, 0.6, 0.65, even better. And your G, the means which how much of the warmth of
I'm still here, don't worry. Well, Roland has joined us from Mannheim in Germany. I know, I see it. So it's as you can see, it's quite challenging. We'll wait for him to get back on track. He was mentioning about the triple glazing. Now, I'm sure that all of you have been going a little bit through the documentation. If you did not do that, I strongly suggest that you go through the documentation which is available on the website, which is the website of the students. And within the this website, you will find a quite big, well, big is not the right word, quite complete documentation. One of it is a multi-comfort house in hot climate. And this is an analysis of multi-comfort house in several climates. One of it, it's Madrid. And you will be able to see there what are the recommendations in terms of glazing. As Roland was mentioning here, he was speaking about triple glazing. In some cases, you can reach the same levels with double glazings. You will see what are the situation or what is the result of using certain typologies of ventilation. For example, if you try to make flash ventilation, which means that you open the windows during the during the night to get cold air inside and to evacuate the warm air, you will see the evolution of the temperature and so on, and you will be able to to have a much better or more clear image of what it means in terms of the construction details. Furthermore to this, what I would add is that it is not that complicated as principle, or it's not at all complicated as principle. The question is to treat correctly all the points. Once you have done that, you are within the right philosophy. If you are with the right philosophy and you are doing it step by step, then everything will fall in hand one after another. Now, the main 10 points that Roland will also talk about once he joined us back. Thermal insulation, no cold bridges, or if you wish, no thermal bridges, air tightness, the glazing, ventilation, heat recovery, internal gains, external shading, and low heating and cooling load. As I mentioned to you a little bit earlier, if you take an action, you will see this affecting also the other. I have Roland on the phone. Just 1 second. He's going to set it up again. Now, if you are going to make a thermal insulation, providing that you are selecting the right one, you can have, or let me rephrase that. Let's say that you are having a building which looks pretty much like this. It's nothing fancy. And let's say that you are going to make some kind of insulation here in front of it. It's an external thermal compound system, and here you are having a road. Depending on the type of the insulation that you are going to select it, beside the fact that you will have an influence on the thermal insulation, you can have a direct influence over the sound. You can either stop it with the right type of insulation, or you can have a negative effect that by putting some insulation in front of an external wall, you can decrease the comfort inside, meaning that you will overall decrease the performance of the full construction. So it's a question of what kind of insulation you are going to select. Furthermore, as I already mentioned, also maybe some of you were already yesterday, the same principle. I think I can open some kind of yeah, I should be able to open some kind of empty slide. I don't know how to do that. Maybe let me check here. No, doesn't matter. I'm going to use the same. Page. Already discussed about it, and you will see it. In our cases, with the balconies, we are having something like this. If I would look at the section, supposing that the balcony is not closed, you are going to run some kind of insulation here in front of the building, or you can run some kind of insulation in front of the building there. Then in this case, yeah, you will have some kind of width. This width will have a direct effect over the sun coming in this apartment. So if you are increasing very much the thickness, you go for a 20 or you go for a 25 centimeter of insulation or even more, then you need to take into account this. Either you need to take into account this effect. You can solve it either by taking or replacing the windows with windows which are having a transmission with a better transmission than the previous one. Either you can increase the surface of the window, but if you increase the surface of the window too much, then you will decrease the acoustic properties also. So this is just to underline one more time that they are interconnected. It's not that you do something and the others stay like they are. And that's the reason for which this training, it's also focusing on giving you the main points on each of this comfort dimension, and we start first with the thermal behavior. Back to Roland now. Are you having your mic set up, Roland?
1, 2, 3. Test.
Yes.
Okay. So, thermal. Sorry for this interruption. My system was down. I don't know what happened. Sorry. I think we just continue. The 10 points. I'm not sure how much Gabriel could explain now, but this is the ranking I found out thermal bridging or thermal insulation, thermal insulation with no cold bridges, That means, especially in the renovation, a lot of detailing, airtightness, triple glazing, air ventilation, heat recovery. Internal gains means people and electricity and so on. External gains, which is basically sunlight. External shading, which is against overheatings and low heating and cooling demand. And to give you a picture of what these certain points mean, I have my house, the renovation of my house. I'm just sitting in this ground floor here already right now. It's a renovation. The house is built first in 1920, so almost 100 years ago. Second World War, it was demolished. The upper part, the lower part, so the cellar is still original. And after the Second World War, they built the house again. So it was kind of well, easy, cheap, but good place. What we did, thermal insulation. It's a renovation, so it's quite similar. I mean, this house is much smaller what compared to the house you are asked to think about, but the system is the same. The envelope. What can we do to the envelope? Of course, we can run some external insulation. You see that here with the mineral wool over the facade of the house, and you also see in this picture here we run the mineral wool also along the roof, the sloped roof here. That was easy. But the question was how to get the ceiling of the cellar, for example, especially with no cold bridges. So cold bridges is the very difficult part. And here you see what we've done to the cellar. We opened up the ground and we got some insulation down 150 or something, almost 2 meters down into the ground, and also on the inside. So we calculated the thermal way during the concrete and found out that about a meter down the ceiling, we had to run insulation on both sides. And especially connection to, for example, here, windows. You see, the window came with its own foam, which is the gray one. And here we've got the mineral wool. But there was little bits and parts where the craftsmen couldn't work that exactly, so we had to get some foam in there. So every little detail has to be fulfilled with the insulation, so you have no cold bridges. Very important. And then the MVHR system, the air tightness, which works together. You need the air tightness on the one hand side to have no difficulties in your building physics. On the other hand side, you need it for an efficient MVHR system. Means you have the test. This is called blower door test. Yeah, you have this ventilation in one of the doors, and you get under pressure and over pressure to the building, and you need to have this air exchange lower than 0.6 times of the volumes per hour. And to get this, you have to really seal all your devices, your pipes, your cables, and so on, which are running through this air tightness layer. Then, of course, we had this already, the triple glazing. Triple glazing is not just a good idea because it has a good U value. It also is a challenge, for example, by the weight. If you have, like you can see on this picture here, quite a big size window, triple glazed, and it has a weight. And this weight can't be lifted up and mounted by 1 or 2 workers as with smaller windows and maybe single or double glazing is possible, but not if you have a window 3 meters by 2 meters 50 with triple glazing. This one weighs between 600 and 700 kilos. That means you need to have a big grant. In your student contest, you will have the same challenges. You will have to change windows on the back side of the building towards the yard, the inner yard, and you have to think about how do I get these windows there. And if you give this answer, you will be you will be recognized as somebody who thought a bit further than just to make a drawing and a section and say, I need to want to have a super glazing, but I don't know, and I don't think about how does this glazing get in place. Air ventilation system, second challenge in a renovation, because air ventilation system, you see here on the right hand side in the picture, the size of piping is not quite like a cable. It has quite a dimension. And if you are thinking about putting 6, 8, or 10 dwellings on it, it's even bigger than the ones you see here. So we are talking about the size of 200, 250, 300, 350, maybe 400 millimeters in dimension. And you have the air in and you have the air out. So you've got at least 2 pipes. And think about where to run these pipes, how to run it, how to do it, and give us the answer. Not just draw some lines somewhere. Give us the answers, how to get there, how to do it sustainable, cheap, and constant. The system itself, the heat recovery system, super easy. There's an exchanger, there's 2 ventilators, there's filter, and that is it. Here you see an old recovery system, but it's still the same today. Here you've got the exchanger, here you've got the filter, and here you've got one, and here the second ventilation. Super easy. But you have to place it. Think about, does it best be in cellar, in some dwellings, in under the roof, on top of the roof, wherever? There might be a lot of answers. Internal gains have to be calculated, especially people. So you have 2, 4, 6 people in a dwelling. How much gains do you get from the electric devices which are used in your dwellings? Very important. And of course, external gains means, for example, in which direction, or especially in which direction does your building face? And is there some shading somewhere? Or do you have to get shadings on the outside, like here, for example, some examples, to prevent overheating? Because overheating, once you have a very good insulated shell envelope, then the overheating can't go. Once you create an overheating inside, it takes a long time to get this overheated outside again, because it works like a canister, like an insulated canister. So you don't want to get overheating. Not to get overheating, you need shading on the outside. Think about it, calculate. And we are talking about 15. If we are heading for the goal of new build, we are talking about 25 kilowatts per square meter a year. If we are talking about renovation, in between, you should be able to get it with the climate of Madrid. It shouldn't be that difficult to get in between towards 15 kilowatts per square meter a year for heating and cooling. Very important. So we have different climate zones on the planet itself. Yours down there is not that critical. It's the moderate climate zone. But just to give you an idea, from moderate and cold climate zones, just briefly, in moderate and cold climate zones, you want to have the insulation and the airtightness layer around the building. You want to have your triple glazing in addition. You want to have your daylight getting inside, and you have to calculate your inner gains as said, and you want to have your exchange, your heat exchange. And what you don't need is a conventional heating system. If you have, for example, hot climate, and you're just in between the student contest task, Madrid is just in between of hot climate. In the summertime, it's quite hot, but it's not definitely by definition a hot climate, but it's in between hot climate and moderate climate. And you see, hot climate does need also insulation and airtightness layer around the whole building, but you see by the size of the yellow line, it's not that thick anymore. So it's not that important for preventing the heat losses and against overheating. But what you want to have is this maybe overhangs, balconies or whatever. So you want to get the, the outer shading to prevent overheating. And maybe you need, or you want to have, it's quite easy and it's very efficient, a night cooling. So a system that you might be able to open your window and then heat recovery. And what you don't want to have, you don't need to have, is ventilation system for cooling, for active cooling. No, might be good thing. Sometimes this dehumidification, but in Madrid, I suspect that you don't have to think about it twice. So I give you an example of a new build in Germany, just to show you the reaction of the design of the different directions once you try to optimize passive house design to the building. So this is in Frankfurt City. It's 5 buildings, one here called A second one here called B, third here C, and this one is also included in the C, and this is D. So, but it's 5 of them, and it's called Sophienhof, which was, for example, the first multi-dwelling house in passive house quality ever built. 149 dwellings. Important, 111 of those are owned by the owner or are used by the owner, owner occupied, and only a third of it, a quarter of it, 48, are rented out, which is by the behavior of the user different. And then a few commercial units in the ground floor area and 156 parking lots underground. And this is the parking lot area. It's outside of the passive house envelope. You see these orange displayed staircases. They are inside the envelope, the passive house envelope, but the parking lot itself is natural ventilated outside the envelope. The passive house envelope starts with the layer, with the level of the street, which is the ceiling of the parking lots. So ground floor and all floors above are passive house quality. And you see, for example, where are we? This is the way the buildings are placed on the parking area. So all the area has an underground a building, and the passive houses is on top. So it's not covering all the area, but it's of course covering these areas of the staircase. They run down to the parking lot. And for example, the A, here's north. On the right, 45 degrees up is north. So that means this inner side to the courtyard is facing almost south. And you see this from the north side, the same building from the north side. Small windows, not that many windows, staircases where you don't need, or it's not that big deal to have if you have too warm or too cold from the, or you have, let's say, more or less external shading, external gains. For example, this building here, the B, looks kind of similar to the street. Also, not that big areas of windows, staircases, and for example, to the inner courtyard, it looks like this, totally different. Why? On the one hand side, because this is the courtyard, and you want to have the living side to the courtyard, and you don't want to have the balconies, if possible, to the street where it's noisy. But this one is also the south-facing side, and you can see by the shadow here, the balconies have this size. So in summertime, they have a natural shading of the windows, which prevents the building from overheating. That was the design idea behind this kind of decision. And on the gable wall, we have almost no windows because this is north facing. And interesting here, this is the gable wall, a thermal image of the gable wall, nighttime, winter time, and you can see here is a car which is just parked and has still a warm motor because it was running, and also the inside of the car is a little bit warm, and the same temperature you find here around this window frame. And we have been astonished about this, found out that this window was slightly opened. That was the reason for it. The rest here is all dark blue and even more blue here, which means dark is, you can see it up here, it's maybe 8 degrees or something, which is cold surface. That means not a lot of a good U value, not a lot of heat is coming through this wall. And we just changed over to the other side to an older building, same street, same time, same direction. Neighbor's gable wall was looking like this. So it was quite warm. It's about 10 degrees, 11 degrees, 12 degrees, somewhere around there. And you can also see the ceilings. You even see the partition walls from inside. You see even white here, which is very warm, 12 degrees on the outside, even more here, where window is opened or bad window frame, or here little window area. So a lot of energy, a lot of warmth is coming through these walls because the U value is bad. So section of the building shows the situation, and you can learn something about this. Even this is a new build and you are thinking about renovation, but you can learn how to do it from this. We had to find a way to run the insulation. Okay, the facade and the roofs, no problem. But then we come down to this ground floor slab, and we come down to the area where the parking lot is outside of the building, of the envelope, of the passive house envelope. So you see here, there's a slight insulation above the floor slab, which you cannot do. The floor slab can't be touched anymore in your student contest situation, but you have the same situation that you're losing something through the floor slab. So you might have to think about, how do I run? How far do I go with my insulation down there? Do I, for example, go here a little bit also? I don't want to give you the result, but I want to think you about it. And on the other side here as well, we run the insulation all the way down, and the airtightness layer comes with it, and we run it along the ceiling and the wall, and we calculated that point here as a cold pitch, but we know how much energy is going to get lost here, and in balance to it, we decided the thickness of the insulation on the envelope. Also interesting here, we decided to have the MVHR system in the staircase area, so we are not losing any space in the dwellings, or have to have an extra house on top or something like that. It's inside the house, very efficient. The housekeeper can come to and exchange the filter anytime he wants to. He doesn't have to go to the dwelling and so on. And from here we run the central heating pipe towards all this different levels and different dwellings, and also the second one for the exchange extract air. This might be a very efficient idea also for your student contest task. So, and lighting, solar gains and lighting comes together on the one hand side. On the other hand side, you want to have a balance. So what you want to have, or what we did here, we didn't want to have to run outside shading on the window because it blocks your view. But we didn't want to have this overheating. by the solar gains because it's almost south facing. So we decided to have these balconies as shown in the other pictures. So the balconies gives you the possibility to stare out, have a view in the garden in the inner courtyard, and also gives you the shading in the winter time and in summertime when the sun is steeper, coming in a steeper angle. We have the solar gains in the house. So you have to find the balance between winter, summer, looking outside, going outside, and having natural lighting. I mean, this room you see has a lot of natural lighting because it has big windows, and still there will need and not be any overheating problems. On the north facing, on the east and west facing side, we could make it different than we did. We have some normal size, let's say normal size windows, maybe they're a bit bigger than normal size because they run to the ground. But we also have, you can see it now, but you can imagine by looking at these details here, we also have the possibility, here you can see it, it's closed here. We have the shading which runs down, but then the view is blocked. This view is not that important because it goes to the street side, but you have to deal with that. Want to have the view, don't need to have the view. Want to have the sun, don't want to have the sun, and so on. This is important, and you have to think about it and get your design connected to these questions. Within the dwelling, that's where we come down with the central piping, and within the dwelling, we have very short ways to the rooms. You don't have to run all the way through the room to have your ventilation system, but you have, for example, this gray area here is a suspended ceiling, 15 centimeters suspension here, and there is the piping. Red one is the fresh air, yellow is the used air, and we reach all the rooms with with very short piping. And outgoing air, we have this easy looking covers and supply air to throw it all the way from here to the room. We have another kind of cover of the piping. And for example, the costs, not very important for your project, but just to give you an idea, it's 1,350 euros per square meter, which is was by then, this is 10 years ago now, was by then only 3% above the average cost level of social housing. So 3% was the investment in this quality of passive house and good, healthy air, which is paid back already by the low driving bill of the building. And what we also did, and this could also be a nice idea for your contest as well, we wrote a user manual for the inhabitants and the facility manager, because it's not difficult, the passive house, but you have to understand what's happening, that you are hardly losing any energy, but you are gaining a lot through the windows, and you have this heat exchanging system running. Because some of the people, they say, I want to open the window because I need fresh air, and they're not realizing that they get constantly fresh air through the heating system. But if you, in the wintertime, for example, open your window and your heat bill rises up, then you might complain and say, "Whoa, it doesn't save the savings are not realized at their promise," and this is not true. You give these people a user manual, and you'll be fine. And for example, in your student contest, we are the people. You have to give something to us. And if you have the idea of just give a short description how to use the building and what is the tricky points about the building, might get some extra points for it from the jury. That was this kind of presentation, and now I'm open for your questions.
Open for questions, guys. Let's see. Yeah, back on the sound. So no questions. Come on, don't be shy. You don't get another chance with him. Okay. We'll give them 2 more minutes. How's the weather in Mannheim these days?
Super. We had a warm, sunny day.
Wow, great. Come on, guys. Ivana, let's see. For me, it's fine also. It means that you know everything that you need to do for the part linked with thermal comfort.
Yeah.
Okay. So, if this is also okay, just to let you know that the presentation will be uploaded on the website. Again, I strongly suggest to all of you to read the existing documentation. Furthermore, to the presentation that I made, I believe I have here. Just allow me 1 second. Yeah. So as I mentioned already, Roland, everything is clear, which is extremely encouraging. It means that you will get very clear presentation also during the international stage. I just want to pinpoint for you one thing. This document, which is called the Multi-Comfort House, I think Roland lost his signal again. Nevertheless, here you have this document which is called Keep Coal in Hot Countries, Save Natural Resources. You have it on the website, on the download area. And this, it's a study which will allow you to see, when speaking about warm climate, what are the design principles, some of the construction examples, ecological impact, and of course first introduction parts. And I'm only going to take you very briefly through it. So you can see here the climates, and if this is the characteristics, the consumption characteristic, energy consumption characteristic of a building in Central Europe, this is Germany, you can see here the other analyzed climates. So you have here Porto, here you have Madrid, so Madrid is analyzed, and here you have Sevilla. You will notice that basically the values are more or less if you take into account also the cooling, because the heating and the cooling are part of the thermal comfort. You do not think only about keeping it warm during the winter. You have to keep it also cool, let's say, during the summer. And here you have about 70% heating plus cooling. Here you have about 75% 65% heating plus cooling, and here you have about 66% heating and cooling. And this can be both solved with a careful design when speaking about thermal comfort. Here you can see some of the elements. So basically, the buildings that we are discussing and the building that we are discussing, it's here, and your scope would be to reach this one. And here you can see also some of the effects. I would just like to pinpoint directly to some of the findings. Let me see if I can remember by heart. So, 1 second. Yeah. You can see, for example, here, I'm not going to enter into the details, but just to give you a flavor, you can see here the effect of the color over the temperature in the living room. Yeah? Depending on the color, if it is a colder one or cold color or a hot color, you can have a difference as much as 2 degrees, only taking into account the color of your building. So this will also affect your design. Furthermore, let's see, this is a thermal mass. Then you have some examples about coupling to the ground, about the movable shadings. Then you can see, for example, the analyze over the night ventilation, and I'm just going to make it slightly bigger. So here you can see what is happening, how is the temperature over the night in Madrid. So you have the best example, it's exactly Madrid. This is the ambient temperature. It can go around 21st of August, around 40 degrees, and then it shifts down by a factor of 10 or maybe 15 degrees in the night. And here you can see what happens if there is no night ventilation, if you are having a tilt windows or if you are having an open windows, and you can draw yourself the conclusion when looking at these figures. And last but not least, you also have some characteristics about the behavior of the material when speaking about the environmental effect and the sustainability effect. That, for example, in the case of the mineral wool, up to 80% can be recycled content. It depends from country to country and so on. I'm not going to enter too much into detail, but I strongly recommend you giving it a read, because this is basically a design document for a multi-comfort house in hot climate, and luckily within the analyzed climate you are also having Madrid. So again, plenty of the questions, you will find the answers here. Any more questions, guys? No questions? Okay, then I will say thank you for being present to this second training. I will welcome you tomorrow, if my memory serves me well. We are going to speak acoustics. We are going to see what it means on one hand, the part where you speak about stopping the noise, and the part where you speak about having a nice environment from acoustic point of view. I'll try to give you also some hints. As mentioned before, what happens if you open the window? If you think about doing the ventilation with a tilted window and you place your building quite close to a very noisy area, what happens and what is the effect of the windows over the performance? What happens if you put ventilation and you do not think about making or having quiet ventilation system and so on. So that would be from my side. You have time for a last question. If not, again, thank you so much. See you all tomorrow. Thank you, guys. Take care. Ilian, you can close down the room within 1 minute. Thank you to all of you. Thank you, Roland. Take care, guys.